And welcome. Today we'll be considering question 3. The formula A union B intersects C union D does not have a well-defined meaning unless parentheses are added. What are all possible sets this formula can describe for possible placements of parentheses? Illustrate your assertions with suitable Venn diagrams. Take a crack at this yourself, then you get some hints, and then we'll proceed with the solution. So for some hints, we will see that there will be 4 solutions, and you should try to illustrate each of them independently, and you should try to illustrate them on the same sets. Additionally, it may be useful to try to expand each of your formulations to show that there are other ways of describing the set that are equivalent. Alright, with that, let's proceed by doing this systematically. So for our first step, we'll let A be an independent one. Let's leave A union B and break that up. So that means we at least have this set of parentheses here. 1 second. So we're going to have A unioned against B intersect, and then we'll call this C union D. And that'll be our first set. Next, we'll have A union, and then we'll have B intersects C, union D. We'll note that we actually don't need this outer set of parentheses, since the union operation of 3 sets doesn't matter the order the sets are in. So this is another well-defined operation. It doesn't really make any sense to try to break up the A union B by sequestering the A like this, or by including the union like this, because that doesn't make any sense. Therefore, we're done with having A union B be separated. There are no other logical ways of breaking up the rest of the sets. So we'll put A union B together. We have intersection, and since we recall that intersection operates on 2 sets, let's make another set out of C union D, and we have 2 sets that we can intersect with one another, and we have our answer. Next, let's keep A union B together, but this time, instead of having C union D be the other set we're intersecting against, let's have it be C. Then we have our full thing, which we'll note is very similar to our first set construction, except kind of reversing the order of the parentheses in some sense. With that systematic way of going through it, having A union B being split up and then put together and considering all the options, we see that we've created all the possible meanings. Therefore, we're done. We can then illustrate these, and a good example to illustrate these on is a set independent from a triplet of sets who share things. If we label this one A, B, C, and D, we'll see that A is included in this set and this set in its entirety. However, we will see that it's not included in these ones. And in particular, it's not included at all in these ones. Since A shares nothing in common with C union D or C, then no element in A will ever show up in either of these sets. Then looking at the rest of the sets, we'll see in this set D is included. In this set D is included in its entirety. And then in some of these intermediate sets, B intersects C is included in this one. In this one, we have, we can expand this out using some of our rules for the operation of union and intersection. And you'll see that you can highlight it in such a way that you have all of the elements that are in B and C and D, namely this little section in the middle. I'm sorry, C or D, so this whole section along this edge here. And union that against the whole set of A. Finally, for this one we have C union D and A union B, but A union B is just going to be B in this sense because A shares nothing in common, and C union D is all of these 2 sets, so that's the same set we just highlighted, so we highlight it again. Finally, for this one we have A union B intersects C, so that's just B intersects C, and then all of that unioned against D. With those descriptions, you can find it useful to illustrate them for yourselves, but we're finished. Thank you.